So today we are going to move on to proportion applications. So we've already spent some time on setting up or using cross products to solve proportions, and now that we know that, how do we set up word problems? So I'm going to use some highlighters. I encourage you to do the same here. When you're setting up word situations, the key thing is that you set up a proportion in one of two ways. Technically, if you flip the proportions, it can be four ways. Either you're going to be given the same units, and you're going to put those same units. Notice this is an A and this is a B, or sorry, an A and an A. It's just that there's going to be a unit. Let's assume the capital A goes with the larger one, and then the same unit with the smaller one. And then you would set it across the unit it's comparing it to, which would be the larger and the smaller. The second way you can set up a proportion is, and this is, I'll just show both ways. You can put the words that are different units but put them together. So if I said, like, I read 5 books in 2 days, I would have 5 books in 2 days on the same fraction. If you're going to do that, you would want to keep the same units on the top as are on the top of that proportion. So either you're going to have the same units stacked on top of one another, or they're going to be right across from each other. What you're never going to see is the same units diagonal from one another. Never, ever. That's how you know we get into trouble. So I am going to circle. A jogger runs 2 miles and burns 185 calories. I'm going to put those in one color. How many calories, that's my unknown, would he be burning jogging 3.1 miles? I'm going to show you the way that I would set up that proportion. So if I decided to put the different units on the same side, I would say I'd put 2 miles here. And to make sure I'm doing this right, I like to put the actual words, and 185 calories over here. And so then on the other side, I would want to put miles on top and calories on the bottom. And so my other color was 3.1 miles. And I don't know how many calories, so X calories. All right, now when you start doing your cross multiplying, please don't use the words anymore. I'm just writing them in, so I'm keeping that straight. Another way you could set up that proportion is you could put the same units together. So the 2 miles goes with the 3 miles. Okay, so the 2 miles with the 3 miles, but then I'd want to go back to the 2 miles. I would want to put the 185 calories over here with the calories I don't know. Okay, so those would be the 2 types of proportions you could solve. When you're solving these, what you're going to notice is when you cross multiply, if I do either or, you get the same thing. Like on this one I get 2 times x, on this one I get 2 times x, and this I get 3 times 185, and I get the same thing. So either one you're solving, you should get the same cross products. So I do that, and I get 2x equals 3.1 times 185. I encourage you to, along with me, get your calculator out. 3.1 times 185. So now I have the equation 2x equals 573.5. I divide by 2. And X equals 286.75. And the units on that would be calories. Okay. So let's go ahead and set up some proportions then. Three pumps can remove a total of 1,700 gallons of water per minute from a flooded mine shaft. If the engineer wants to remove at least 550 gallons per minute, how many pumps will they need operating? So it looks like the units here are pumps and the gallons per minute. So as I'm setting up my rates here, or my proportion, I'm either going to do the pumps over the pumps and the gallons per minute over the gallons per minute. I tend to want to do the rate that goes together, so that's my personal preference. I like to put 3 pumps goes with the 1,700 gallons per minute. And once again, I'm just writing that down to help me set up my proportion. Once it's set up, then I don't use the units in the cross multiplication. On top, I have to put pumps. I don't know how many pumps. I'll just put P for pumps. And the gallons per minute on the second mine shaft, or I don't know if it's a second mine shaft, but they want to know how much they would need. Okay. So I'm getting that from the 3 pumps can get 1,700 gallons per minute, and I want to remove 550 gallons per minute, and I want to know how many pumps. So that's where those two kind of units or comparisons are coming from. I cross multiply. I get 1,700 P. I cross multiply here. I get 3 times 5,500. And when I multiply 3 times 5,500, I now get 1,700 P equals 16,500. I divide by 1,700. And I get 9.7 pumps. Well, that's not going to work. Can't have 9.7 pumps. You are going to need at least 10 pumps to do that work. Okay, let's do a couple more, looking at what kinds of things I ask you to do. Let's look at the recipe question. A cookie recipe calls for 3 eggs and makes 4 dozen cookies. So 3 eggs goes with the 4 dozen cookies. How many, this is in dozens, cookies could you make with a dozen eggs? Okay. So I'm going to go ahead and put my 3 eggs on top. I'm going to put my 4 dozen cookies on the bottom. That's not 4 cookies. 4 dozen is actually 48 cookies, but we're measuring them in dozens, so I'll put 4 dozen. On the other side, I need to put eggs. A dozen eggs. Well, that's 12. How many dozen cookies could you make? Well, I'll put D for dozen cookies. All right, drop out the words. 3D equals 4 times 12, which is 48. Divide by 3. D equals 16 dozen cookies. 16 dozen cookies. Okay. Let's do one with ratios, because ratios also can be written as a proportion. And so ratios would be like if you're comparing or you're mixing things together, like this is a paint ratio. And so to mix paint, if you've ever gone to a paint store, which maybe some of you have, typically they mix different colors together to make the color you want. And so in this case, a certain shade of green paint is made from 5 parts yellow mixed with 3 parts blue. Okay, so this certain shade needs 5 parts yellow mixed with 3 parts blue. Okay, so if 2 cans of yellow are used, how many cans of blue should be used? Okay, so no matter what a ratio means, it's going to be the same ratio, but the units can change. So I'm going to put the parts yellow to the parts blue as my fraction or ratio. So 5 yellow for every 3 part blue. So that's what that goes with. And those would mean for 1 can of paint. So that's why I highlighted it in the same color. This now gives me a measurement of 2 cans of yellow. It's yellow. I need to put it up there. So 2 cans of yellow. I don't need the word cans. Just know that this is yellow. Just put a Y there for yellow. Down here is going to have to be blue. How many cans of blue? I don't know. You can call it B for blue or X. Okay, so cross multiply. 5B equals 6. So if you were doing this, it would be a partial can, but it would be 1.2 cans of blue should be used for that. Okay. I'm just looking ahead to your assignment to see if there is any kinds of problems that I didn't cover. I think we're good. So I have these 3 examples. What your assignment is going to be today then is you are going to go on to page 10 and do the worksheet on proportions applications. And that should be an assignment on Google Classroom, which you should submit. And then tomorrow, for similar figures, I should be here to be back to teach that lesson.